Hello everyone, thank you for joining me for my presentation today. It's such a pleasure to share our work on leveraging large language models for generating smoking cessation intervention messages with you. Successful health communication requires well-written, accurate, and persuasive messages to achieve attitudinal and behavioral adoption. In the context of smoking cessation, our team have developed smartphone apps to help people quit smoking. And within the 6 months of intervention, the app prompts messages to raise awareness, increase efficacy, and promote abstinence. The mobile health approach has demonstrated its effectiveness through a series of clinical trials. However, its success depends on substantial high-quality intervention messages. For us, it took our counselors and researchers several years to develop a message bank of 900 messages, but that's way not enough for longitudinal design. Considering the need for high-quality intervention messages and the time-consuming nature of creating them, the study proposed to utilize AI systems for message generation in healthcare. This research represents an interdisciplinary collaboration involving researchers from substance use intervention, health communication, and machine learning. Nowadays, we can utilize large language models for generating intervention messages. And here are some sample messages generated by various large language models. As you can see, some of them are accurate and persuasive. However, there are also messages that may be inappropriate or contain misinformation. Therefore, when we look at AI today, it serves as a transformative force in public health, offering opportunities to enhance health communication through its advanced language capacities and medical knowledge contained in the massive amount of training data. However, it also raises concerns regarding its accuracy and safety of adopting such technology in clinical practices, especially considering the high-stake context of healthcare. Against this backdrop, the study aims to explore the clinical applicability of large language models in the context of smoking cessation. In particular, it focuses on two research questions. How could we optimize the model to mimic human expert writing? And further, if we succeed in optimizing the model to mimic human expert writing, do these model-generated messages meet the clinical standards to be ready to adopt in our smoking cessation interventions? To explore the two research questions, we conducted a series of 3 studies. The first 2 studies focus on optimizing the model performance through prompt engineering and decoding optimization. In these phases, we utilized our expert-written message bank as the benchmark for training large language models in generation of intervention messages. The prompt and decoding strategies that yielded messages closely resembling human expert writing will be identified as the most effective, and therefore be selected as the optimal solution. To increase the generalizability, the study utilized 5 state-of-art open-source large language models, including the GPT model, the Bloom model, and 3 OPT models, varying in sizes.
Having large language models communicate using natural languages. The input we provide to these large language models is known as a prompt. Since large language models generate outputs based on the inputs they receive, the way a prompt is crafted can significantly influence the quality and relevance of the message output. Therefore, in the first study, we employed a featured learning method to provide large language models with a prompt that includes both a task, description, and 4 exemplar messages written by experts. Specifically, we tested 5 different types of prompts. The first 3 prompts varied in the level of detail in their task description, ranging from a general instruction such as message, to a more detailed ones that specify the task, message theme, and preferred tone, like write motivational messages to encourage people to quit smoking. The fourth prompt introduced a revised structure, presenting messaging exemplars first, followed by the task description. Finally, the fifth prompt employs a structured format, explicitly labeling both the task and the message exemplars. We sent a prompt to each model and repeated the message generation process 100 times for each model. To ensure the message's relevance, we employ a 2-step filtering process, including a repetition filtering and a context-specific criteria filtering. Then, we conducted message evaluation to identify the optimal prompt that generated messages most closely resembling human expert writing. In addition to using perplexity metrics, we introduced a computational linguistic approach. Research in the field of health communication has highlighted key linguistic features indicative of high quality and trustworthy health messages. For instance, messages that convey a natural emotional tone or utilize complex vocabulary tend to be perceived as more objective, professional, and trustworthy. Thereby, we adopted 5 linguistic features, including word count, cloud, emotional tone, authenticity, and use of complex words as evaluation metrics and quantify each dimension for generated messages using the software Look. 5 prompts were rigorously and comprehensively assessed based on 3 key dimensions: diversity, quality, and efficiency of message generation. Diversity was evaluated using perplexity score and pass rate of repetition filtering. Quality of large language models generated messages was evaluated on critical linguistic features, benchmarked on human written messages. Then we examine how efficient the message generation is based on the average number of messages retained per iteration after the 2-step filtering. On benchmarking expert written messages, we discovered notable deviations between message generation by large language models and human expert writing. Among the 5 prompts analyzed, the findings indicate that prompts with general instructions outperform those with detailed and specific instructions, with prompt versions 1 surpassing versions 2 and 3. Furthermore, the considerable underperformance of prompt version 4 highlights the ordering effect of instruction and exemplars on model performance. Additionally, prompts structured in a clear format demonstrated superior performance, as seen with prompts versions 1 and 5. Based on these results, we recommend employing succinct and structured prompts, as exemplified in version 1, for message generation within the healthcare context. In Study 2, we conducted the decoding optimization following the message generation and evaluation processes in Study 1. A decoding method interprets large language models' output probabilities for the subsequent token in a sequence and select the most suitable one for text generation. In message generation tasks, the selection of decoding method is critical for achieving the optimal balance between message diversity and quality. In this study, we employ 3 decoding methods, including temperature sampling, top case sampling, and nucleus sampling, as well as a hybrid approach that combines these 3 approaches. Overall, results reveal a coherence diversity trade-off that lower perplexity scores were associated with higher message rejection rates due to repetition. However, a hybrid approach, as in decoding version 1 and version 8, could achieve optimal model performance and balance diversity, quality, and efficiency by employing higher K values with lower P or temperature. Through studies 1 and 2, we addressed the first research question. By utilizing a computational linguistic approach, we introduced new metrics for the automatic evaluation of messages. We further recommended solutions for optimal model performance, including the use of a structured and succinct prompt combined with a hybrid decoding approach. Having identified these optimal solutions, we then moved to the clinical evaluation of messages generated using these methods to determine whether these large language model generated meet the clinical standards to be adopted in our smoking cessation counseling program.
During the clinical assessment, 7 certified tobacco treatment counselors assessed the quality, accuracy, credibility, and persuasiveness of the intervention messages on 10-point scales. They were then instructed to make a binary judgment. Based on their training standards, will these messages meet the clinical standards to be ready to adopt in the smoking cessation interventions? For clinical evaluation, we also involved messages generated by the newly released ChatGPT, which is powered by the GPT 3.5 model trained on the OpenAI's 175 billion parameter foundation model. Each counselors evaluated 100 messages, stratified and randomly selected from the output of 6 large language models, along with the human expert reference condition. Here are the examples of the sample messages along with their evaluation. The results from the clinical evaluation suggested that ChatGPT outperformed human experts in terms of generating intervention messages. In fact, 71% of the messages generated by ChatGPT is rated as ready for clinical use, as compared to a pass rate of 48% from human experts. Furthermore, the comprehensive evaluation of message quality, accuracy, credibility, and persuasiveness suggested that ChatGPT significantly outperformed human experts in terms of generating high-quality messages, and they achieved equal performance for message accuracy, credibility, and persuasiveness. In addition, larger language models like the OPT-30 billion and OPT-30 billion models achieved equal performance of human experts. On the other hand, smaller models like the GPT-6 billion model, the Bloom 7 billion model, the OPT-6.7 billion model consistently underperformed human experts. Through systematic optimization and clinical evaluation, our study has proposed optimal solutions for message generation in healthcare. In addition, our comprehensive clinical evaluation has for the first time established the clinical applicability of large language models in enhancing health communication and intervention. This addressed the long-standing safety and accuracy concern regarding utilizing large language models in healthcare. In future studies, we plan to examine the inter-reader reliability regarding message evaluation, as well as increase the sample size of the evaluated messages. And further, build upon the clinical applicability of large language models in healthcare, as supported by this empirical work, we plan to develop the chatbot-delivered smoking cessation intervention messages and recruit smokers for clinical trials. This will allow us to further explore the user experiences and feedbacks regarding adopting such technologies in clinical practices. And I want to wrap up my presentation with acknowledgments to my co-authors, the tobacco treatment counselors, as well as the funding agencies. And thank you for listening.